Oh yeah, it was clean. Okay. Oh yeah, I haven't got my alarm set up yet. Okay. Good morning, good morning. Good morning. On another dreary day. Okay, so first things first is just a couple of quick announcements. Number one, tomorrow morning, your next week's folder should pop up. So you'll be able to see what we're planning to do next week. I need to go in and do a little bit of editing because of, well, last week, but we'll get there. So the second announcement that I want to make is I have extended office hours today. So 9:30 to 10:30, well, 9:30 to 11 is the official office hour. However, I'm going to be in my office from 9:30 to 1:30 and then again from 2:30 to 5, well, 2:40 to 5. So there's lots of time today that you could come see me because don't forget you got quiz 1 and quiz 2 where you actually have to come see me. So, and as a reminder, my office is Manion. What? 203C. It's kind of in the middle of the building on this side. So, any questions for me before I get started into today's material? Okay. Well, then we're going to go ahead and get started into today's material. The very first thing we're going to do is talk about drawing organic structures. The previous chemistry course, you discussed, whoops, let's get a pencil here. You discussed Lewis structures. And in those Lewis structures, you would show where all the bonds are. And where lone pairs were. And it probably took a little bit to draw. Now, the first type of formula we talked about was that of the molecular formula. The molecular formula itself is very, well, to be quite honest, it's pretty nondescript. For this particular compound, that would be C2H6O. You don't know where the O goes particularly or anything of that nature. So again, it's very nondescript. Then we discussed structural formulas. The only difference really between a Lewis structure and a structural formula is we tend to leave off the lone pairs. So we would put in the CH, H, H, CH, H, OH. Still very tedious to write. Now we can speed up our lives a little bit by doing what's considered to be a condensed structure. And essentially what a condensed structure does is it takes each of these carbons and describes what's on the carbon in bits and pieces. So the very first one, this first carbon has C and 3 H's on it. So it would just condense it down to CH3. The next carbon has 2 hydrogens on it. So it would condense it down to CH2. Then we would get into where the actual alcohol comes into play. And we would show that as the next thing, which is the OH. So that would be a condensed structure. It still takes time. You're writing out every single element and it takes a lot of time. Now, these condensed structures, they can be written this way, or you might even see them written as CH3, CH2, OH, where you actually see the OH bonds. But still, you're writing out every single element and showing pretty much where it's connected. Now, condensed structures are actually useful, especially when you get into a molecule such as CH3, CH2, 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 1, 2, 3, 4, 5, 6, 7, 8, CH2, COOH. I wouldn't have wanted to draw that out using a structural formula. So this is definitely a better situation. But it's still a lot. Now, I will say when we get to these slightly longer molecules, we can do a further condensed structure. If I can spell, it would be nice. And what we do with further condensed structures is we take all these CH2s and we just condense it further. So all these CH2s here are identical. All those CH2s are absolutely identical. So instead of writing out the entire thing, we'll write out the CH3, but then we'll open a parentheses and we'll say, okay, there's CH2, close parentheses, how many CH2s? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. And then we've got the COOH. That definitely made our lives a lot easier. And when we get into talking about your carboxylic acids that go into making lipids, this is the type of formula that you'll probably see, is this condensed structure where we put all the CH2s together and don't actually write out all the CH2s. Now, none of these tell you anything about shape. They don't tell you what shape every single carbon has. The first one that hints at shape is a line or line angle structure. This is going to be the very first one that actually will hint at shape. Again, it only hints at shape. It is not going to tell you, oh, it's tetrahedral. Oh, it's trigonal planar. It just starts to hint at what the shape is. Now, with this, the reason it is so much easier is because the end of a line, so when you have this type of structure, the first thing you need to know is that each carbon-carbon bond is represented as a line. The second thing you need to know is that anywhere a line ends or begins, as well as the vertex, of two lines, represent a carbon. Third thing to know is any element besides carbon and hydrogen will be shown. And the last thing you need to remember is that carbon has to have 4 bonds. So the number of hydrogens is understood based off of 4 minus the number of bonds showing on a carbon. So when I draw the line structure, let's see, I need that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of those points represents a carbon. Now to get that C double bond OH, I've got to show the double bond or the COOH. I've got to actually show it because it has to be shown. The only things not shown are the carbons and the hydrogens. But the carbons are represented at each end. So the end represents a carbon and at each vertex. So we know that each of these dots that I'm drawing is going to be a carbon element. And then the number of hydrogens on the carbon is 4 minus however many bonds is attached. So on this one, it would be 4 minus the 1 bond, or in other words, there are 3 hydrogens. On this one, whoops, there would be 4 minus the 2 bonds showing. So in other words, there's 2 hydrogens. Any questions about that? Yes.
Can you back up and explain the 4 minus 1 again and how you get 3H?
Okay, so it's 4 minus however many bonds are showing.
Okay.
So on this carbon, there's only 1 bond showing. Because there's only 1 line attached to it. Whereas on this one, there's 4 minus, there's 2 lines showing. So it's 4 minus 2, so there's 2 hydrogens. Other questions? I like questions. That's one thing y'all don't have to worry about. You're welcome to ask me questions. Yes.
So with the one on the very end, be like 1, since there's the 3.
On this, so there's actually, that's a great question. So let's look at this. There's 4, so we take it 4. How many bonds are currently attached? 4. So there would actually be 0 hydrogens on that particular one. Because the double bond counts as 2, and then there's 2 single bonds also. I'm glad you asked that question. Other questions?
I might be getting ahead of myself, but what would like the name of that molecule be?
This is so octanoic acid.
Okay.
It may also have a generic name, but I can't remember the generic name right off the top of my head.
Okay, that's the name I was looking for.
But octanoic acid, because it is carboxylic acid, so we put in the ic acid, and it comes from 8 carbons, so octane. So yes, this will be octanoic, and you are a little bit ahead, because that's what we were getting to next, is how to name compounds. Or not next, but very soon. Other questions?
Would a question like this be like, or like an exam or a quiz for you? Like, what would you ask?
So I can ask this in a variety of formats. As we get further into the chapter, I could give you the name of a compound and ask you to draw it. and specify that I want the line structure. That is one way to go about it. Another is to give you the line structure and ask you for the name. And I won't include, until we get to the chapter on carboxylic acids, I won't include naming this as an oic acid.
Okay,
It would have just been a straight chain alkane.
okay,
But it would be something along those lines. So I'd either give you the formula and ask you for the name, or I'd give you the name and ask you to draw me a line structure. Something along those lines.
so you won't ask anything about how many hydrogens will be in it?
Oh, I could. I could ask you the number of hydrogens. I could give you this. Another way to do it is I could give you this and ask you for the condensed structure. So basically you need to be able to go between any of the three structures in the name.
Okay,
I will promise I'm not gonna ask for too many structural formulas. Those will most likely be given just simply because they do take a long time to write. So it will be mostly, give me the line structure or the condensed formula, is the way it's most likely to be worded when I'm asking you to give me something. You may have one where you have to draw a structural formula, but I'll try to keep that to a minimum simply because they do take a long time to draw. Did that answer your question sufficiently? We're actually gonna do some of that once I get to the naming. I wanna kind of combine this section and the naming section together.
okay,
So we are gonna get to where we're gonna practice, but I wanna combine some two sections together. Okay, so before I get into naming, the next thing I wanted to do is, again, this line structure hints at the shape of the molecule. But it really does not get into the shape of the molecule. We would have to get into using darkened in wedges to tell us that something is coming towards you, or dashed wedges to say that it is going away from you, or straight lines to represent that it's in the plane. And I don't know how much of that you did in your previous class. But we would have to get into that in order for you to actually draw the structure to show me the shape. But, so what I've done here is I've built a molecule. And this molecule is simply designed to help you understand that, to be quite honest, there's a multitude of shapes. If you have nothing but single bonds, you have infinite numbers of drawings you can make. To help, I have got the two green dots. They're representing two of the 6 hydrogens on this molecule. Now, with a single bond, I can rotate it and rotate it and rotate it and rotate it and rotate it, and I can keep going. They can be side by side. They can be at an angle from each other. They can be complete opposites. That's the problem with this. What I just described to you, where we can come up with an infinite number of shapes simply by rotating the bonds, is called conformers. So these are conformations of one another. I also did it with the benzene ring. I mean, not benzene, but butane. I also made a butane molecule, so you can see similarly what goes on. So again, we're going to look at the carbons that I have my fingers around, which is the middle 2 carbons. I can rotate the bond because it is a single bond. And I can come up with a ton of different conformations. So in order to draw this, we would have to draw a ton of different conformations in order to draw the actual structure. Now, some of these conformations are more favorable than others. This one is actually a more favorable conformation because the CH3 that I'm holding in my left hand and the CH3 that I just grabbed are on opposite sides. Whereas if I rotate it so that they're on the same side, they start to clash. That's called steric hindrance. And steric hindrance can change the type of reaction that a molecule can undergo. So if they can clash, they can change the type of reaction a molecule can undergo. Now I'm going to pass these around. We're not actually going to get into conformers with respect to an alkane. They're important, but they're not the most important thing. But conformers are going to become more important as we talk about alkenes and as we move through the double bonds. That's where the conformers become more important. But it was introduced in the alkane chapter, so I wanted to at least go through those terms. So you really have 3 terms that came out of this particular section. Conformations. CONFORMATIONS. Which is the various 3D structures that a molecule can have. For an alkane, that is an unlimited or an infinite number of conformations is available. The second definition is a conformer, which is a single 3D structure of the molecule. And the last is steric hindrance. Nope. Always have to look at how I write it and then decide which one it is. Steric hindrance. And this is this occurs when there is greater bulk on one side of the molecule Okay, so those are the 3 terms. Again, these 3 terms really aren't too big of a deal for an alkane, but they will become more and more important as we get to other functional groups. I'm going to pass my 2 molecules around so that you can actually see better than me just holding it up here in front of you. See what I was talking about. And that does take us into the key thing for today, which is naming. And I will spend a good portion of what's left, if not all of what's left, taking and going over naming. And then combining naming with condensed and structural and line structures. So practice. Why am I going to spend so much time on this? What I'm about to lay down is the foundation. We are going to use this same foundation as we progress through the first 6 chapters in naming. So by getting the foundation solid, it's going to help you when we go to alkenes, which is our and alkynes, which is our next set of functional groups. It's going to help you when we move over and start talking about alcohols and ethers and esters and amides. So it's the foundation for all of that. So I think we need to spend a little bit of time and make sure that you've got that foundation before moving forward. It'll make going through the rest of them a little bit faster. So, okay. So I actually began at the back of this section and then moved through each piece. So to name an alkane, the first thing you need to do is name the main chain. The main chain is going to be the longest alkane chain. You're going to identify it by putting your pencil down and drawing a line and finding the longest straight, not straight, the longest line. It can be crooked, but you want the longest line that you can draw. Now, once you've identified that main chain by drawing that longest line, then you're going to name it. And the names that we will be using for the main chain are in table 12.2. I will not ask you to go past decane for now. So 1 carbon is called methane. 2 carbons is called ethane. 3 carbons is called propane. 4 carbons is called butane. Then it actually gets easier. 5 carbons is called pentane. 6 carbons is called hexane. 7 carbons is called heptane. 8 carbons is called octane. 9 carbons is called nonane. And 10 carbons is called decane. Now, one reason I said it got easier is if I ask you for the geometric shape that has 5 sides, it's called a pentagon. That's where the pent came from. If I asked you what is the geometric shape of a stop sign, which has 8 sides to it. It's an octagon. That's where the oct comes from. So in other words, when you get to 5 on through 10, the prefix is the same as the name of the shape for that number. It's only 1 through 4 that have different prefixes that don't match the shapes of molecules. I mean, excuse me, geometric shapes. Okay. Once you've identified the main chain, step number 2 is you're going to number the carbon atoms in the main chain. And when you do this, you want to start on the end closest to a substituent branch. Or, as we'll talk about later on, the functional group. Step number 3 is to identify the substituents on the main chain. This is found in figure 12.3. In your textbook. But I'll also do them here so that you have a record of them in case you don't have the textbook as of yet or something of that nature. So the very first one is a CH3 group attached to a chain. And I'm gonna, well, I don't want to do that. Let me, I'm gonna use a squiggly line to represent where what it's attached to. This is called a methyl group because that's what it comes from, methane, and methane was a single carbon. The squiggly line just represents the rest of the compound. The next one is a CH3 CH2 group. Well, if I have 2 carbons, what was it called? Ethane? Well, this is called an ethyl group. The next one is CH3 CH2 CH2. And what was a 3-carbon alkane called? Propane? Well, this is propyl. Now it's going to get a little bit more complicated. Because in this particular one, the main chain was on the end carbon. Of the substituent. However, we can have instead of it coming off the end carbon, you could have it coming off the second carbon. And this one is called the isopropyl group. The next one has 4 carbons on the end one. And this is referred to as butyl. The next one has the main chain. Attached to the second carbon. And this is called sec-butyl. The next one has the main chain attached here, and this is called isobutyl. And the last one has 3 CH3 groups around the carbon that's attached to the main chain. And this is called tert-butyl. Sometimes also called T-butyl. Okay, once you've identified your substituents, step number 4 is to write the name. As one word. And it combines the first 3 steps. You will use a number to identify where the substituent is. You will use a dash to separate numbers. I don't want to use that symbol. That made it more confusing. Let's try that. From name, from letters. If you have it, you'll use commas to separate numbers. But ultimately, you write it in the order of name the substituents, in alphabetical order, followed by the main chain's name. Yeah, comma just to separate in alphabetical order. Trying to be
Oh,
literature.
no, I'm doing-
Oh, yeah, that's a comma. Sorry. Okay, now it's time to do some practice. I'll do a few and then I'm going to give you a couple to do. So that you can see how I approach it. And then we can go from there. So we're going to start simple. I could have written that in this format, but you also need to be prepared for it to be in this format. Those would mean the exact same thing. Or I could have written it in this format. All three of these mean the exact same thing. Step number one. Well, let me give you a second to catch up with all the structures. Whoops. Step number one is to identify the longest chain. I can put my pen down and go 1, 2, 3. I can put my pen down and go 1, 2, 3. I can put my pen down and go 1, 2, 3. Basically, what I'm showing you is no matter what I did, 3 was the longest I could get. So this is going to have the main chain is propane. The next thing is to number the carbons so that the substituent is on the lowest number. So I can number it number 1, number 2, number 3. Or it could have been numbered 1, 2, 3, or 1, 2, 3. It did not matter. What you will notice is that the substituent always wound up on number 2. So the substituent is going to have the number 2 associated with it. And I'm going to get rid of some of these extra numbers and just focus on one. I just wanted to illustrate that it did not matter which way we went. Now, what is that substituent? What is this substituent that's on number 2?
Well,
This is the methyl group. So you have all the pieces. Now we're going to put it together. So this would be called 2-methyl. And we write it all as one word, propane. And that would be the name for that compound. Questions? Let me give you a minute to digest where you're not writing. Go look at the steps that I gave you. And basically this is step 1, step 2, step 3, and then I'll put it all together. Now, before I move any further, there is one more thing that I wanted to discuss related to these carbons. And that is the term primary carbon, secondary carbon, tertiary carbon, and quaternary carbon. They actually told you one way to recognize it in the background, and they based it off of how many carbons is it attached to. I'm going to do something else. I find that it's actually simpler. How many hydrogens are on it? A primary carbon will have 3 hydrogens. A secondary carbon will have 2 hydrogens. A tertiary carbon will have 1 hydrogen. And a quaternary carbon will have 0 hydrogens. So for me, it's easier to count the hydrogens than it is to say, okay, how many of these? It's less confusing. So on this, the one we just did, this is a primary carbon because it has 3 hydrogens on it. This was a primary carbon because it had 3 hydrogens on it. This was a primary carbon because it had 3 hydrogens on it. But the middle one was actually a tertiary carbon because it only had 1 hydrogen on it. Let's look at another example. Because it's going to bring in one more thing that we will have to do. Okay. So the first thing I want you to do is attempt to name it. I will say that because there are 2 substituents and they are the same substituent, we use prefixes. And the prefixes that we use, if there are 2, it's di. And if there are 3, it's tri. And this gets attached to the name of the substituent. So I want to give you a moment and just start working through the 4 steps. Anybody want to tell me what the longest chain was? Pentane. With its 5 carbons. Who wants to tell me where I should start numbering? Left side or right side?
What's that?
Why do I start numbering on the left side? Because it's the closest to the substituent. So I'm gonna have a substituent on number 2, and I'm gonna have a substituent on number 3. What are the substituents? Are they both methyl? Yes. So I got to put it all together. So it's going to be 2, 3 dimethyl pentane. It is telling you that there's 2 methyl groups, one on the 2 and one on the 3 is how it on the pentane chain. Let me give you another one. If you have to, rewrite this as a condensed structure. Okay, let's see how it's going. So you're struggling with this type of structure. Again, what you can do is you can start by rewriting it. So there's a carbon at every single juncture and at every end along the way. So we have a CH3 group. So we have, and then the longest chain where I can draw and keep going. Was 6. So I could rewrite it as 1, 2, 3, 4, 5, 6. And then off of this one, there was a carbon. Off of this one, there was 2 carbons. Whoops, not a, well, there is a hydrogen, but, and then off of this one, there was a carbon. So sometimes getting it down to where it's not as chaotic looking is very useful. So step number 1 was to identify the longest chain. And we just discovered it was 6 carbons, so that is hexane. Step number 2 was to number them so that it's closest to the nearest substituent. So you would have had to number this one in reverse. Because otherwise, if I would have numbered it this way, my first substituent would have been on 3. Whereas by numbering it the way I did, the first substituent was on 2. So you always want it to be the lowest number. So we would number it from right to left in this case. So we have substituents on 2. We have substituents on 3. And we have a substituent on 4. Step number 3 is to identify those substituents. Well, on 2, it was a methyl group. On 3, it was an ethyl group. On 4, it was a methyl group. Now we got to combine it all. And I noticed at least one person did it slightly wrong, because you got to remember, you got to do it alphabetically for the substituents. And E comes before M alphabetically. So we would have called this 3-ethyl 2,4-dimethyl hexane. In other words, the di doesn't count. It's what is the substituent? Methyl, ethyl. Questions? It takes practice. So guess what homework 2 is going to have a lot of? Naming practice. And also identifying whether it's primary, secondary, tertiary, or quaternary. Which I think that's the easy part. The naming's the hard part. So I want to take a moment because I don't want to run out of time and we're down to 5 minutes. So homework 1, I posted on Tuesday. I will go upstairs over the next little bit and get homework 2 posted now that I know what we covered. Homework 1 and homework 2 are due on Monday at 11:59 p.m. So before I see you next time. Well, no, we're not going to wish missing lab. Before I see you in here next time. The functional group scavenger hunt, which I mentioned on Tuesday, you need to print it off and it should be completed and turned in on Monday at the start of your lab. I take things printed off. I don't, when it comes to labs and stuff, it's printed. I'm not one that likes to grade on Blackboard. I find it to be a pain in my tail. So, you'll also need to print off the Alkane Dry Lab and bring it to lab. Now, here's what I'm planning to do in lab on Monday. On Monday, I'm gonna finish up the lecture associated with chapter 12 about the alkanes. All that we have left are the properties, which isn't so bad, the reactions, which isn't really that bad, and then a quick discussion of cycloalkanes. So I plan the first hour to be lecture and the last hour to be working on the Alkane Dry Lab, which is an isomer lab. So technically, folks, if you really feel like you want to get it done, you could you've already got the tools. You could probably do the isomer lab. And that way you wouldn't have to stay the full time if you don't want to. Or you can come in and you'd be able to ask questions during lab. So you got a little bit of flexibility there because it's not a wet lab. So again, that Alkane Dry Lab, you need to print and bring to lab. And then quiz 1 and 2, I just wanted to bring it up. It is, as a reminder, it's due next Thursday. And I will be posting, the Blackboard should go live at 8 a.m. tomorrow for next week. I've got to go in and edit what we're going to do because obviously we are way off on schedule, but that's as far as where I expected to be topic wise. But that's okay. We're going with the flow. Got to keep reminding myself we're going with the flow. Any questions?
Do you have any book problems to practice this?
I will get you some book problems, and the problem is I am going to get you some book problems. I think I have an answer key already put together, but I'm going to have to handwrite the answer key for the first chapter. Now, I have purchased an answer manual, 2 of them. One to stay in my office where you can come by, check it out, and go out into the hallway and check your work. And the other one I will be putting over in the library on reference. But I just got those ordered because they wouldn't send me a copy, so I had to pay for them. So I just got those ordered and they will be coming in for you. But I think I've got some for 12. I just need to double check that they're correct, that the numbers line up, because I don't remember if it was this textbook or a previous textbook that I used. So I will work on that this afternoon too. So this afternoon I will post your active homework. I will post I will get you some homework and answer keys out of the textbook, and I will make sure that what goes live tomorrow is up to date. Yes.
Can you read some sections for Monday?
Oh, for Monday. So for Monday's lab, go ahead and read 12:7, 8, 9, and 10. 12:7, 8, 9, and 10. And then for Tuesday, we will get into 13:1, 13:2, 13:3, and 13:4. I will try to start posting those. When you look at Blackboard, I typically name them almost identical to whatever the name of the section is too, to help out. But I'll update Blackboard. Yes. For Monday, pages are 384 to 394 for Monday. Okay, I will stay around for a couple of minutes to answer any other questions, but I don't want to keep you because some of you may have class. And I will also take any comments, concerns that you might have about how things went. But I'll see you Monday otherwise, unless I see you in my office first. Yes,
The quiz 1 and 2, that's a separate quiz in 1 and 2 from this, the ones that do today, or are they due next Thursday?
they are due next Thursday because it's all done.
So we don't have to come to the office today.
No, you can come to the office today, but you have to next week. Because it's just all done. Because there's 2 carbon. Okay, so once you number it, 1, 2, 3. Then you look at it.
Last week, I was thinking, I thought it was
Yes,
10.
so that had to be.
Sorry.
Yes, that's okay. Actually, no, the 2 is this one. And the 4 is that. So it's telling you where the numbers tell you where the constituent is located on the chart. Correct. So there's an ethyl located on number 3 on the chain. There is a methyl located on number 2 on the chain. And there's a methyl located on number 4 on
Just a quick question. So how come this usually is not?
Oh, it's still go in the same chain. I just made it a lot easier by, I actually went, okay, that's 1, 2, 3, 4, 5, 6.
But we're not coming.
And so I just made it straight to make my life easier.
Okay. But it doesn't matter if like it's not listed.
No, because it's not a substituent. It's part of the, if you had to find the main chain, which is the longest one you can draw without lifting your pencil. So I could go 1, 2, 3, 4, 5, 6.
Okay.
And so that actually became the main chain.
I see. So it's.
And so I just made it easier by writing it out in a straight line.
Okay. I was confused by that.
And that's one reason I went ahead and drew it like that. Is so that hopefully you can get that confusion out.
Yeah.
Where you can ask that question.
Yeah. Okay. Well, thank you.
Have a good day.
You